About a concept from industry. Some would call a buzzword or a hype. And yeah, I would like to talk about how it connects Snap with Lego and this Rubik's Cube. But first question, who can actually solve it? One? Only one?
The instructions.
Okay, then it's your task for the next 15 minutes to solve it. No grades. For the others, sorry, you won't learn it today. 15 minutes is way too short, or it's not enough time to teach it. But I'd like to talk a little bit about an idea that I had for this project. Actually, I introduced it as a buzzword or a hype. I used to work in the automotive industry for the last 10, 12 years as a software engineer, and they really stressed me out with this digital twin. Oh, nice. They really stressed me out with this concept of digital twins because they were everywhere, especially in the factories. Everybody was talking about, we need digital twins. A lot of marketing was going on. But let me tell you a little bit about what actually a digital twin is. The definition, it's the only slide. The definition is that a digital twin is a virtual representation of a physical object, a real-world object. And both the digital twin and its real-world representation are connected. So every change in the physical object is mirrored to the digital representation. And on the other hand, every action that can be simulated in the digital version can be executed on the physical object. I think the most important point here is that we really need a physical twin. So it's not an abstract thing. It's not something in our mind. We really need an existing physical thing that we try to model and that we try to interact with. And that's the idea I wanted to share with you, because I think in the industry, they use it for, they have digital twins of their gigantic, whatever, press lines in the manufacturing factories. They collect data, they do things like predictive maintenance. And the really interesting part for me, when I remembered my first computer science lessons at school and also at university, there was always this big message: a task or the goal of computer science is to model parts of the real world. And that really made sense for me. But then in practice, I can remember we modeled and we built a library management system. Completely abstract. Our school even hadn't a library. So this was not very, or was underwhelming and not very tangible. And I wished that we modeled something that we can take in our hand, that we can have a look at, that we can interact with. And that was the goal with this project. Enough introduction. I think let's have a look into Snap. I sat together with my son. My son is 8. Credits to him. He built the thing not by his own. It's an open source instruction guide, but yeah, he helped me. We sat together and tried to learn actually how to solve this cube. So if you can't solve it, really learn it. It's cool. Even with 37 years, it was a hard time for me to see how an 8-year-old kid can do this faster than me. Really cool. We sat together, and it was a time I quit my job at the as a software engineer, I had this concept of digital twins in my mind as they brainwashed me with it. And I thought about, hey, let's build such a digital twin system with Snap, because I started my position working with Valve, and Valve told me about Snap, and I had to have a look at Snap. And that was the point where I thought to build such a system. I mean, modeling such a cube isn't that hard. So it has 6 sides, 9 pieces at each side with a color, and it has an orientation in the room. So on the modeling part, it's quite simple. So we have a list of we have a sorry for that. We have a list of sides, front, left, right, back, bottom, whatever. And each of these sides has also a list of color items. And that's the actually state of the cube, so our model. But as for now, it's only an abstract model because we didn't have the combination with a real cube. And that's where this Lego robot comes in. So we need something to interact with, or we need some device to interact with this cube. And that's where we found this Lego robot. Usually there's some MicroPython firmware running onto the Spike Hub. So it's a Lego Spike education kit. And usually there's a ready-to-use MicroPython implementation that actually solves the cube by its own. My goal was no firmware on this Spike Hub. I wanted to build this digital twin system completely in Snap. And that's where I started to figure out that things are more complicated than I thought, because the first question was how to interact or how to speak with the robot, how to, there's a out-of-the-box firmware running on the Spike Hub that listens on the serial interface and has a MicroPython interpreter running. So this was the first first step to communicate with it. And with that, it was possible to communicate with it. And now we can interact, we can turn, we can flip the cube, whatever. So that was the first step. But as for the concept of digital twins, what we need is that we need to know the actual state, so the color pattern of the cube. And this is something it can be done with the color sensor. So there's a little color sensor. We will have a try, because the color sensor has a problem. He has a problem with yellow, orange, and red, which is a problem because, as you see, there's yellow, orange, and red on the cube. But for now it's running. There's also a problem with ambient light. We will see. Yeah, it's running, and I didn't mention. So okay, we have a 2-dimensional representation right now. 6 sides. This is the front one, up, down, right, left, and the back one. It's not the fastest one. Maybe I can share who knows the video of the fastest cube solver available, this 0.1 second solver. It's mind-blowing. this one is a little bit slower. Okay, now it's turning it again and again and again. Okay, scan is valid, so he checks it by counting colors. Every color has to be there 9 times. And yeah, we have I implemented two different approaches. So the first one, I thought about, hey, let's use this device to actually learn how to solve this cube. And hand-solve means, you will see it, that the cube is displayed and you see actually the right moves that you have to do. And you can do them by your own. Today, I'd like to show the RoboSolve mode, which is actually the, for me, cooler part. When I thought about digital twins, it's not about having the model in the computer, but also see the digital twin. And that's where I found something really cool, some really cool Snap project. There's an implementation by, no, it's not my part. It's
good to say. I was hoping you were going to involve it.
Yeah, it's a user named Kuluk. I don't know if he's here or listening online or who he is, but he implemented this cube, and it's mind-blowing because in the original version you can turn it, you can rotate it in the room, you can even rotate the single sides. And if you have a closer look, now this is the actual digital twin of this cube. It's the same state, it's the same colors pattern. And so now the last part, I don't know how the time is. Let's try to solve it. Okay, and now he starts to solve the cube. You see the actual pattern, it's synchronized. There are 2 versions of this project, to be very honest. There's one version where the solving algorithm is implemented in Snap. So the complete solving algorithm. It's not so easy to build such a solving algorithm and implement it. As you see, humans can do it very fast. But there's a second version that runs the solving algorithm in a web service. And for the demo here, I used the version with the web service because it's much faster. So the Snap implementation is definitely slower. Hopefully it works. Looks good for now. Oh.
Your project or your son's?
Oh, it was my project. It would be really cool if my son can code things like that. It would be really good. So that's the technical side. Maybe just as a wrap up. So I want to make one to three main messages with this project. So actually you can combine Lego Spike and Snap, and there's a way to communicate. It's not beautiful because we really pipe MicroPython code over the serial interface. It's not so cool. Snap, or you can solve Rubik's Cube with Snap, which is cool. But the main message is this digital twin concept isn't just a buzzword. So the idea of really trying to find objects that you can model, and while you're modeling them or while you interact them, be able to touch them, to rotate them, to even destroy them is a cool thing, which, yeah, adds context to project, and on the other side makes learning more tangible. That's it. Thanks. I will add my GitHub repository in the in the chat or in this project area. And within the GitHub project, there's this. There are the building instructions. There is the link to the Snap project. There are some more videos, and there's also this for the second option, this function code that runs the solving algorithm within a web service. Yeah, everything that's needed to build it.
The robot can only make certain kinds of moves.
Yes.
So like it can rotate the bottom
Yeah.
layer. Did that affect the solution algorithm? I'm sorry. Does that affect the solution algorithm that you chose? Is it tuned up for?
If you would try to optimize the algorithm, it would, but I actually only yeah, there's a step. So a rotation on the upper side is a flip and the flip, and then a rotation on the bottom side. That's
is rotation, then a flip, and
a rotation in the middle is actually not possible.
well, if you flip the bottom and the top, then it rotates the middle.
Yeah, the rotation in the middle is a rotation of the bottom and the rotation of the top. There's no rotation because the middle parts are fixed, so you can't rotate it in that way.